We're going to learn a new word here. It's called proportion. So when we have things in proportion, we're keeping things consistent and balanced when we're comparing their size. So the same size should go from here to here. So even as it gets bigger, it's keeping that same comparison. Everything is consistent. So here's just a little think about example. So if I have this circle here, even when I blow it up, you can see that it's the same kind of distance here. Where this one, all of a sudden, this circle didn't grow at the same rate the other one was. So this is not consistent, or this is not proportionate. These are proportionate, so even when it got bigger, it just sustained the same comparison there. So we're keeping things consistent and balanced. So that's what we've been doing with all of those charts that we've been making, is we've been making proportions as we go along. We're keeping things in proportion. So we need to remember that fractions are just division problems. So if we have 2/5, that is just really 2 divided by 5. We're just doing division problems here. If we go all the way back to our definition of a ratio, it's just a comparison of two numbers by division, right? We are dividing. This is a ratio of 2 to 5. And we need to remember that the opposite of divide is multiply, right? That multiplicative inverse there. We're going to kind of use that same tool and strategy again. So we have our example. It takes Kendra 27 minutes to run 3 miles. So 27 minutes to go 3 miles. So we have a rate here. We have minutes and miles. We have two separate things that we're comparing. And at that same rate, right, we want to keep that same proportion. How long will it take her to run 7.5 miles, 7.5 miles? So before, we've been finding the unit rate. How much is 1? How much is 1? But now we want to take that and apply it in a new way. We want to keep that same proportion. So we're going to keep our same setup with those tables. We just aren't going to put the lines in them. So we have minutes, so we need our label. So first thing first, we need our label, minutes. And we're going to put minutes on top and miles on the bottom. Now, it does not matter which one you do. I always just do the first one I read on top and the second one on the bottom. And we're going to say, what does this equal? And we're going to set up these lines like this every time. This is our proportion setup. We have our labels, and we want to know this proportion, this rate equals this one, and we're going to keep them proportionate. We're going to keep them balanced. What we do to one, we have to do to the other. So every time we start with our labels, and we have line, equal sign, line, right? This is just like our table, except it just is missing, right? I could put this in a table and go across here, and I could make a table, but every time instead of putting the line, we're just putting the equal sign. That's it. Like, just is missing the outline. That is all we've done. So let me get rid of that. Okay, so we have minutes and miles. So we know we have 27 minutes. So here's my minutes, putting 27 here. And we're trying to go 3 miles. So 3 miles. So 27 minutes and 3 miles. And now we want to know how long will it take to run 7.5 miles. Where do we have miles? On the bottom. So we want to put 7.5 on the bottom. So it's just telling us exactly where to put everything when we read our keywords here. So miles is always on the bottom. We went 3. Now we want to go 7.5. We are looking for this number right here. How many minutes did she go? This is our new setup that we're going to use. So, sorry, I couldn't find my next arrow. So we have this problem, okay? We have this here, and we want to find these minutes alone. This is what we're trying to get all alone. So we already have this. We want the minutes alone. We've got to get this all by itself. So what we're going to do is we are going to write, this meant divide. Minutes divided by 7.5, but we don't know this number. So we're going to move this to the other side, right? We were dividing, and we know the opposite of divide is multiply. We're going to move this to the other side. We're going to crisscross, so circle, 27 and 7.5 in our, okay? So back in your proportions, circle those numbers. So instead of dividing, we're going to multiply them. So we're going to take 27 and times it by 7.5. Then we'll divide it by 3. So our new problem is 27 times 7.5. So we just crisscrossed, right? We wanted this one alone. So we crisscross the two numbers across from each other, right? I can't crisscross this way because I don't know the minutes. So we're going to circle 27 and 7.5. And then we have to divide it by 3. So that's our new problem. So when I do this, we would do 27 times 7.5. So at the bottom or out to the side, go ahead and, or if you have room in that problem box, go ahead and do this with me. So 5 times 7 is 35. 5 times 2 is 10, plus 3 is 13. We're getting a placeholder. 7 times 7 is 49. 7 times 2 is 14, plus 4 is 18. And then we're adding those up. So we have 5, 12, 10, and 2, but we have one decimal place. So now we're at 202.5. We're not done, so we only did the multiply. Now we need to divide that by 3 groups. So 202.5, and we're dividing that by 3. So I need something above the 2, the 0, the 2, here's my decimal, and the 5. So 3 can't go into 2, it goes in there 0 times, but it goes into 20 3 times, which is 18. Leftovers 2, bringing down the 2. 3 goes into 22 7 times, which is 21. 1 left over, bring down the 5. 3 goes into 15, exactly 5 times. So for her to go 7.5 miles, that's going to take 37.5 minutes, right? So we went from 3 to 7.5. That should get bigger. So from 27 should get bigger if we keep that same proportion, right? She ran farther, so it should take longer. If all of a sudden we have an answer like 17 minutes, that's not going to make sense. If it took her 27 minutes to run 3 miles, it should take longer to run 7.5 miles, which it did, 37.5. So we set up our problem. We look for the numbers across from each other to multiply. Because it was divide, but we've got to move it. And we have to do the opposite when we move it. So we multiply and then divide by the other number. So let's try one more of those. So we have a 5-pound bag of flour that costs $2.68. What is the price of 12 pounds? So things, first we need to know our units. What are we comparing? So we have a 5-pound bag, and it cost us this much money. So we have pounds. I'm just going to put P for pounds, and I'm going to put a $sign for my money. So as long as you know what your labels mean, you're good, but you have to have your labels. Okay, so let's get our setup. So we have the equal sign, or our fraction equals this fraction, because ratios are just fractions. So we know we have 5 pounds. 5 pounds, pounds are on the top. And that cost $2.68. Money's on the bottom, $2.68. And now we want to know the price of 12 pounds. Pounds we have on the top. So we have pounds on the top. So now this time we're looking for this money here. We don't know how much 12 pounds costs. That's what we're trying to find. So last time we crisscrossed this way, but we don't know this one. So we're going to go the other way, and we're going to multiply, because we would divide, but we don't know this problem. So we're going to move this over here, and we're going to multiply. So our new problem is $2.68, and we're going to times that by 12, right? So we have that new problem, and then we're going to divide it by 5. So the one you crisscross is what you multiply, and then you divide by the other number here. So we have $2.68 times 12. So if you have room in the box or down at the bottom of the page or on the side, wherever you can find room, let's go ahead and do that. So 268 And we're timesing that by 12. 8 times 2 is 16. 12 plus 1 is 13. 2 times 2 is 4, plus 1 is 5. Okay, done with those ones. Placeholder, 1 times 8, 8, and 1 times 6, and 1 times 2. So we're adding those up. So there's 6, 11. 11 plus 1 is 12. 2 plus 1 is 3, and I have 2 decimal places. So now we're at $32.16, but that's not our final answer. Now we need to cut it into 5 groups. So we have $32.16, but we are dividing that by, oh, yep, by 5. I was right. Okay. So we need something above the 3, the 2. Here's my placeholder or my decimal, 1 and 6. 5 can't go into 3, but it goes into 32 6 times, which is 30. 2 left over, bring down the 1. 5 goes into 21 4 times. And there's a 0, or 20. 1 left over, bring down the 6. 5 goes into 16. 5, nope, not 5 times. 5 goes into 16 3 times. And now we do, right, so that's 10. I'm going to bring down that 0. And 5 goes into 10 2 times. So if I want to buy 12 pounds of flour, that is going to cost me $6.43. So we set up our problem. What do we know? What are we looking for? Crisscross the ones across from each other and multiply, and then divide by the leftover number. Will tell you this missing piece. So we set up this proportions. This is called a proportional reasoning strategy. We're setting up what we know to compare what we want to know. So make sure that you've colored anything important that's going to help you remember to set up these proportions.